Hello and welcome back to Algebra. We are in Chapter 8, Section 1. Title your notes. Measures of center and variation. When I played football, I played center. If you know anything about football, the center is usually in the middle. Now sometimes that can vary. There might be a few more players on one side or a few more players on the other side, but usually the center is in the middle, shows you the middle. So that's what we're talking about today.
Alright, let's look at a couple of graphs here. We have here the weights of players on a football team. And I can tell you I would have fallen right in the middle here somewhere. Well, actually right here. Which is not the typical weight of a center on this chart, which I can tell you this is a professional football team right here. So, look at these weights of players and see what you notice. And then compare that to the weights of players on a baseball team. Alright, see what you notice here. Okay, notice on the football team, it is way more spread out. Okay, we go from about 180 all the way to 340. Whereas on the baseball team, it's bunched together. It's all right here from about 160 to 245, 250-ish. Now, also looking at this, notice which values occur the most. What do they tell us about the data? Okay, on the football team, okay, we have the values here right around 200, 210, 215 occurring the most. Is that the middle of the data? What about here on the baseball? We have this occurring the most. Does that coincide with the middle of the data, with the average? Then also, do you notice, do the weights in any way relate to the positions that these players play? Okay, are pitchers always a particular weight? Are infielders a particular weight? What about on the football team? Centers and quarterbacks, defensive end, tight end. Notice how the weights are tied to those positions. So that's some things that you can analyze about this data and see how those are different. Alright, a measure of center, or also sometimes called central tendency, shows us the center or the typical value of a data set. And we use mean, median, and mode. You should already be familiar with these. Something that's new here with mean is the symbol X bar. That represents the mean. So if you ever see X bar, you should know that means mean. So make sure you make a note of that in your notes. Median, we know, is the middle number. Remember, they need to be in order from least to greatest. So order them numerically, then it's the middle number. And if there are two middle numbers, it's the average of the two middle numbers. Mode is the number or the numbers that occur most often. Mode is the most. Median is the middle. Alright, let's compare some of these. Mean, median, mode. We've got these hourly wages for students at an amusement park. Okay, these are their wages. We want to compare mean, median, and mode. So the mean is where we add them all together, and then we divide by how many there are. There are 8 values here. Add them all together and divide by 8. X bar is the mean. That gives us $9.65. The median, we put them in numerical order, and then we find the middle. The middle would be right here, but there is no middle number because there are 8 values, so we take the middle 2 and average those out. Add them up, divide by 2, you get 8.7. And then the mode is the number that occurs most often. That's these first 2. So 825 occurs most often. That's the mode. Now, which measure of center or central tendency best represents the data? If you were to look at these and say, does the majority of the students here make somewhere in the vicinity of 965? No, actually they all make less than that except for this one. They all make less than that, so that's not a good representation. Okay, what about this one, 870? Yeah, you could say their wages are all kind of in that vicinity. The mode, they all make that much or more. They all make, that's the least amount. So the mode is not a good measure here, neither is the mean. In this case, the median is a better measure because of this, what we call an outlier. Okay. Let's look at that. An outlier is much greater or much less than other values. Now let's see what happens if we remove that outlier from the data. Okay, so if we take the 1650, if we take that out, remove the outlier, then the mean comes to be 867, which is much more representative of what most of the students make. The median is 865, and the mode hasn't changed at all. Okay, so the outlier, they asked us to describe a possible explanation. So why would one student be making that much more? Maybe he's doing a different job, like he's maintaining the website, which requires some specific skill, while the others are doing less skilled jobs. Like one could be maintaining the website, the others could be game attendants. All right, a measure of variation tells us the spread or distribution of the data. How far is it apart? If you remember the graphs of the football players, those were spread really far apart. There were some really heavy guys at 350 almost, and then some lightweight guys. Whereas baseball, they were all plus or minus right around 200. So the range is the difference of the greatest and the least value. Finding the range here, we've got 2 cooking shows with 12 contestants each. Here are the ages of the contestants. We want to find the range and then compare the results. Okay, so range, remember, is greatest value minus least. So we'd find the greatest value here. We got 31, and the youngest there is 19. So we can subtract those two, find the range. Over here, we've got someone who's 48. And also someone who's 19. So fairly easy to see that the range in B is greater than the range in A. To be exact, range in A is 12. The range in B is 29. So these data values are more spread apart. Okay, a data transformation uses a math operation, so addition or multiplication, to change a data set into a different data set. So if we add a number to every value, the measures of center, or measures of central tendency, of the new data can be found by adding k to the original measures of center. So I could take the original mean median mode and just add that same number. I get the new mean median mode. The measures of variation are the same. They are the same as the original. Range stays the same. If I use multiplication, then I can find the new measures of variation and of center and variation, by multiplying the original measures by k. Okay, let's have a look at what that means. So if I take that same data set from example 1, where I have the wages, and I want to find the mean median mode when the hourly wages increase by 50 cents. And then I want to find the mean median mode when it increases by 10%. All right, let's have a look at that. If it increases by 50 cents, one thing I could do is just add that value to every wage. So the 650 is now 17, and so on. Just add it to all of them, and then find the new median mode. Okay, so I'd go back through, find new mean is 1015, median mode, and the range is 825. Remember, that doesn't change. Or I could find the mean median mode of the original set and then add 50 to the mean median mode. Remember, the range stays the same. So then I could take these original ones and just add 50 cents. Notice I get the same result. Okay, if I want to increase something by 10%. I can either find 10% and add that to it all, or I can just multiply by 1.1. So increasing by 10% is the same as multiplying by 1.1. And so multiplying, if we're multiplying, then we can multiply the measures of variation and the measures of center. And then I would get a value of 10.62, median of 9.57, a mode of 9.08, and a range of $9.08. And friends, that's all for today. Check back again another day for another fun screencast.